So just to recap at where our last video ended, we were computing the distance between, not the distance, the length of this line segment from A to E, and we got this improper integral. So we got, when we computed this, we got that. And as b goes to 0 from the right, natural log approaches minus infinity. So this bit here approaches minus infinity. So the whole thing approaches infinity. So this distance here, so the distance, this length here of this curve, of this line segment, is actually infinite. I'm just going to write this here, but don't treat it too seriously. Yeah? That just means that if I keep going from A to E, I never reach E. So you can imagine what happens as the people who live on the hyperbolic plane look in certain directions. When they stand here and they look in this direction, they see exactly the same thing that we see, because the distances are not distorted. As they go up, you see here the distance is natural log of 2. This distance between this and that would be natural log of 3 minus natural log of 2. That's smaller than natural log of 2. So as they walk at the same pace towards the north, we see them on this representation as walking faster and faster. Because if the flag posts were y equal 2, y equal 3, y equal 4, y equal 5, the real distance between the consecutive two flagpoles is getting smaller and smaller. So if they're walking in this direction, they seem to be, for us, that we look only in this planar representation of the hyperbolic plane, as if they walk faster and faster. But if they walk south, then this distance, this path here is infinite length for them. So they start out going sort of normal speed, but then it looks like they're slowing down, and eventually they almost hold, right? It looks like they're not moving and never really getting there. But that's just because in reality, this path here has infinite length. We don't see this on this planar representation here. It looks to us like it's a short path, but in reality, and reality we're not seeing here, this actually has infinite length, this path. So I asked, well, okay, so what happens when these people get to the x-axis and they look through it? Do they see the end of their world? No, they never do, because they never stand on the x-axis, so they always stand some distance before the x-axis. And from our point of view, it looks like they're close to the edge. But from their point of view, which is the real point of view, the edge, if they wanted to just keep going south, the path that leads to the edge has infinite length. So this world sort of in this direction never ends. As you approach the x-axis on our representation, they keep going slower and slower. For them, the world doesn't look like this at all. It just looks like this thing, the horizon, is actually infinitely far from them. So our goal here for studying the hyperbolic plane is the same as it was for the sphere. Namely, we want to identify what the geodesics on this plane are. And then, once we have geodesics, we can study triangles, we can study circles, we can study trigonometry. And you will see there are some very interesting phenomena happening on hyperbolic plane, just like there were some interesting phenomena in the trigonometry on the sphere. So, I can't stress this enough, right? This is not the real hyperbolic plane. It's just a representation of it. If you lived on a hyperbolic plane, you would never talk about the x-axis, because you can never see it. It's infinitely far from you. That's like the horizon that you can never get to. Going in the other direction, the things, d is a certain distance from a, natural log of 2, but the point 3 is actually closer to 2 than 1 was to 2. 4 is closer to 3 than 3 was to 2, and then 2 was to 1. Right? You can actually exactly compute these distances by using the formula. So that's how this strange word looks in reality, and this is just a representation of it. But it's a good representation because we can make all the calculations. We can see how geodesics look like, so straight lines, how they look like, how triangles look like, how circles look like. So we're going to be using this particular model of the hyperbolic plane to learn a lot about this world that we cannot imagine in reality.